let's take a look at this quantitative command of evidence question, see if we understand the graph. Participants' responses to 3 review conditions, and the mean rating for the participants would be unhelpfulness very high, and on attitude toward the product very low. And between the 3 elements, it looks like it's no anger, high anger, low anger. So that's no, essentially high, and low. So it looks like high anger gets a little lower average rating across the board, whether it's attitude or helpfulness. Okay, so let's read what's going on here. To understand how expressions of anger in reviews of products affect readers of those reviews, business scholar Yin and colleagues measured study participants' responses to 3 versions of the same negative review. So we have a negative view. So that indicates it's helpful was high, but the attitude of the product is low. Well, I guess that makes sense because it's a negative review, right? So a control review expressing no anger was one of the 3 versions. One showed high degree of anger and one low degree of anger. Okay, we saw that from the chart in the legend right here, okay? So reviewing the data, students conclude that the mere presence of anger, so what is that? The mere presence of anger is low anger, right? It's not high, it's just merely present. Or maybe it's low and high together. So the mere presence may not negatively affect readers' perceptions of the review. Okay, so the perception would be their rating, but a high degree of anger in a review does worsen readers' perception. So where do we see that? We see their perceptions of the review for high is a little lower than the low anger case. Okay, so that's true to the graph. Not huge difference there, but there is some of that effect. So, okay, let's check the answers. On average, participants' ratings and the helpfulness of the review were substantially higher than were participants' ratings of the reviewed product, regardless of which type of review. Well, no, that says there's no effect, so that's not consistent with the conclusion. That doesn't support it, right? Compared with participants who saw the control review, participants who saw the low anger rated the review as slightly more helpful, whereas participants who saw the high anger review rated the review as less helpful. That looks like it could be right. I'm not sure about that first part. Was it a little more helpful, the low anger? Yeah, I mean, it's hard to tell, but I would say it's just a little bit higher helpfulness. So I think that's true to the graph, and it actually supports the case. So it looks like B might be our answer here. Let's quick check C and D. Participants who saw the low anger review rated the review as slightly more helpful than the participants who saw the control review did, but participants' attitude toward the review product was slightly worse than when participants saw the low anger review than when they saw the no anger review. It was worse for the low anger than the no anger. Yeah, but that's not really the right comparison, right? So the claim is some anger, good, a lot of anger, bad. It's not versus the control here, which is all this C is saying. D, compared with participants who saw the low anger review, participants who saw the high anger review rated the review as less helpful. Okay, that's true, yeah, and had a less positive attitude toward the reviewed product. They had a less positive attitude for the low anger case. No, they had a more positive attitude. They had a less positive attitude toward the reviewed product. So compared with participants who saw the low anger, the high anger rated the review as less helpful and had a less positive attitude toward the reviewed product. So high anger was lower attitude rating, lower helpfulness rating. That looks true. Is that proving our claim? The mere presence of anger in a review may not negatively affect reader. So it shows it's lower, but is it supporting the idea that just a mere presence? So what does B do that D is different? D looks interesting. and I'm almost wanting to circle it, but B says, compared with participants who saw the control review, right? There's no reference to control review, so there's no control, okay? So mere anger, good. Well, that means we have to test low anger versus control. That's not in here at all, okay? And then a lot of anger, bad. That means we have to show that the high anger is much worse than the low anger. I mean, that's here in D, but the first part isn't, and it is in B. So I think B is the right answer here. Okay, what do we have here? We've got a quantitative question, seed germination with and without H2S treatment. So we see the percentage of germination, okay, and the amount of germination and how they do. So over time, they all improve. The low germination seems to improve the best. And the high germination kind of at first is worst. So let's see what's going on here. In high concentrations, hydrogen sulfide is typically toxic to many plants. Okay, that's why the high amount was bad, toxic. Okay, that makes sense. Frederick Doley and colleagues wanted to understand what effects low doses of hydrogen sulfide might have on plant growth. They treated bean, corn, wheat, and pea seeds with various concentrations of hydrogen sulfide and tracked the germination of those seeds along with the germination of untreated seeds. So the graph shows us that the low case was good. It was actually even better than the untreated. Treatment with particular concentrations of hydrogen sulfide was associated with accelerated germination. Yeah, that's shown in the graph. For example, we're going to see the case with 10 micromoles per liter having the highest germination rates. So let's see what answer kind of shows that. At 24 hours, less than 10% of seeds treated with hydrogen sulfide at a concentration of 10 micromoles per liter had germinated, whereas more than 90% of those seeds had germinated in 168 hours. All this says is that over time, there's more germination. That doesn't really answer the question of the claim. The claim is that low dosage, good, high dosage, toxic, okay? So B, at 48 hours, more than 70% of the seeds treated with hydrogen sulfide at a concentration of 10, whereas only approximately 50% of untreated seeds. This shows hydrogen sulfide better than the control case. Is that our claim? Treatment with particular concentrations accelerates germination. That's it. I think that's going to be our answer. Let's check C and D. At 168 hours, more than 90% of hydrogen sulfide of 10 or 500 per liter had germinated. No, that would be our toxic case. That's not what we're trying to prove. D, at 48 hours, approximately 50% of seeds treated with hydrogen sulfide at a concentration of 10, whereas 30% of untreated seeds had germinated. Okay, so at 48 hours, 50% had germinated, whereas only 30% of untreated. So wait a second, this is the same thing as B. The numbers are different. So did we get our numbers right? Let's check the numbers, see if it's true to the graph. Because B and D are saying the same thing. What are the right numbers? At 48 hours, 10 was 70, and none is 50. B is the right number. D is simply not correct relative to the graph. So right idea, same as B, but wrong numbers. B is the answer. We need both true to the graph and relevant to answer the question.